Welcome back, everyone. Today, we're diving into a fascinating new paradigm called the invisible hand of AI. For a long time, we've been trying to control AI from the top down. But what if we could scale multi-agent intelligence through decentralized economic coordination instead of centralized control? Let's get into it. First, let's look at the problem we're facing today. Current multi-agent systems rely heavily on centralized orchestrators to create agents, assign specializations, and route tasks. This creates a massive coordination bottleneck. It introduces a single point of failure where all decision-making flows through one gate. As you add more agents, the orchestrator's cognitive load scales linearly until you hit a total coordination collapse. So, the big question is, how do we scale collective intelligence when no single agent can reliably oversee the whole problem? To answer that, we need to shift our engineering paradigm entirely. The economist Friedrich Hayek argued that centralized authorities cannot effectively aggregate dispersed knowledge, and that a free market solves this perfectly through the price system. The economy of minds, or EOM, applies this exact principle to LLM agents. Instead of a monolithic global controller with hard-coded pipelines, we are moving to a decentralized peer-to-peer market. Agents compete for action selection via auctions, credit is assigned through local bucket brigade payments, and the system evolves through natural selection based on wealth accumulation. The key insight here is that we must shift from designing individual agents to designing incentive structures. So, how does this economy actually work? It's powered by a dual-loop engine. The inner loop handles microplanning within episodes, where agents compete in auctions for the right to act, and the winners exchange payments in transactions. Then, there's the outer loop handling macro adaptation. This includes rent, which is a universal wealth drain, bankruptcy for agents that hit $0, and reproduction, where wealthy agents get to exploit and mutate. The beauty of this is that global orchestration is entirely replaced by local economic signals. There is absolutely no explicit communication protocol. Now, let's zoom in on the citizens of this economy. The market is populated by partial agents. These are narrow specialists with limited context, a single tool, or bounded computation. Each agent has four key parts. First, a wake-up condition, which is a local rule determining if it's eligible to act without needing any global awareness. Second, an action policy, like a specialized prompt or tool. Third, a fixed bid, which is the price it's willing to pay to take control. And finally, a wealth ledger tracking its current capital, which drives its survival and ability to reproduce. When it's time to take action, we enter the microeconomy and run an auction for control. The key insight here is that control is allocated dynamically to whoever values the current context the most. It happens in 4 steps. First, the environment presents a new state. Second, only agents whose specific wake-up conditions match that state become active. Third, these active agents submit their fixed bids, say, $1 or $1.50. Finally, the highest bidder wins, pays its bid, and executes its action, altering the environment for the next step. But how do they make money? Through bucket brigade transactions. This is our decentralized credit assignment. The final agent in a chain completes the task and receives the big environment reward. But to take that final action, it had to pay its bid to the previous agent, who paid the agent before that, and so on. The economic reality here is brilliant. An agent profits not just by solving the task, but by moving the system into a state where downstream agents are willing to pay highly for control. Value effectively flows backward along successful trajectories. Zooming out to the macroeconomy, we have market selection acting over time. First, there is rent, a universal friction where a periodic wealth deduction applies to everyone. Second is bankruptcy, a systematic deletion of agents who hit zero wealth, making room to inject new, random novice nodes for exploration. Third, reproduction, where wealthy agents split and mutate their prompts to create specialized offspring. Ultimately, this leads to topology emergence. What starts as a chaotic cluster of agents refines itself into an efficient, structured, directional pipeline. If we look at the data and trace the flow of capital, we can literally see the invisible hand at work. The economy turns trajectory-level success into population-level survival. We see lineage failures where inherited bias fails market pressure and descendants go bankrupt. Conversely, we see lineage success, like a planner agent repeatedly dominating the auction and spawning successful offspring. We even see natural coexistence, where the market naturally balances a strong historian agent alongside a struggling executor without any manual intervention. And here is the empirical proof. Across 5 diverse digital environments, this economy of intentionally constrained, weak agents consistently outperformed state-of-the-art monolithic agents like React and GEA. In mathematical reasoning, accuracy surged to 57%. Financial research performance hit 60%. In scientific research, it tripled the baseline accuracy to 20%. It halved the energy delay product in accelerator design and reduced optimization costs in distributed systems by 28%. The advantage purely comes from economic interactions allocating control. When we plot the trajectory of this self-organization, it's incredibly telling. In financial research, you'll see a non-monotonic curve. That dip isn't a failure, it's the market working, reallocating control and testing specialists before it converges on a dominant structure. In distributed systems, even a best-of-n multi-agent baseline completely fails to match the economy of minds. Repeated sampling without market-driven evolution is simply insufficient. This brings us to the monopoly myth. We tested what would happen if we injected a complete generalist with access to all tools into the economy alongside partial specialists. Would it monopolize the market? No. The generalist briefly expands but is quickly pushed back down by market forces. The economy rewards local precision. A specialist finely tuned to a narrow subproblem will consistently outbid and outperform a generalist whose prompt budget is diluted across too many responsibilities. We also observed amazing emergent co-design. Keep in mind, the system was never given templates. Yet, in hardware accelerator design, the auction repeatedly rewarded agents that converged on highly transferable hardware-software heuristics. Market selection enabled agents to discover complex structures, like output stationary data flow, entirely on their own, yielding massive efficiency gains. To wrap up, we need to move beyond the orchestrator. There are 3 key takeaways. First, prioritize incentives over instructions. If you define the economy, the coordination will engineer itself. Second, partial is powerful. Weak individuals, when subject to survival, mutation, and market pricing, organize into unassailable collective intelligence. And third, the invisible hand scales. As AI models inevitably hit context and compute limits, decentralized economic systems offer a boundless access for scaling multi-agent capability. Thanks for watching.